Okay, this is chapter 4, section 1, nth root and rational exponents. And I'm going to go over some basic ideas, some things that you guys probably saw in Algebra 1 and Math 2. First section shouldn't be terrible, but there's some stuff that maybe you don't remember. So we have, let me see if I can get this to zoom in better. Okay, so this little guy right here is known as the index. It has a little n listed here. This thing is not contrast every time. I'm using something new that I haven't used before. And then this is the value inside the square root. So I'm just going to write square root here. Okay, so the way or the formula that this is listed, the base value that's underneath the root is your a, and this is going to be raised to the 1 over n power. Trying to get this thing to work. It keeps going in and out no matter what. Okay, so I'm going to give you a couple examples. So there should be some basic ones. Let's see if you have something like this. Now, pretty much everybody knows the answer to this. Square root of 9 makes 3. We all know that. But one of the little things right here, if it doesn't have a value on the index, it's assumed to be a 2, which means what two same numbers multiply to make 9? Well, 3 times 3 does. That's why the reason's 3, because it's 2 of the same numbers. Okay, and then the way you would write this for a calculator would be 9 to the 1/2, because whatever the base is, this value that's inside the square root, that's your 9, and then look at the formula, 1 over n. Since this guy's a 2, 9 to the 1/2 power. Okay, so let's say I had one that looks like this, cube root of 8. Okay, this means what 3 same numbers multiply to make 8? Well, those 3 same numbers that all multiply to make 8 is 2 times 2 times 2. So the answer for this guy would be 2. It's 3 of the same values. The way I would write this to plug into a calculator is 8 to the 1/3 power. Okay, now to show you how this works on a calculator, here's my little handy calculator that I have here. I'm going to clear it out. And I'm going to plug in 9 raised, this is the little power button, to the 1/2 power. Hit enter. There's your 3. Now let's try this one. 8 raised to the 1/3 power, which is this guy right here. Hit enter. It makes your 2. Okay, so we just verified that those were right. Now let's do some that don't come out necessarily pretty. Let's say I did one that looks like this. This says what 4 same numbers multiply to make 20? Well, I could write this as 20 to the 1/4 power. Now, if you think about this, if you tried to say, well, what 4 same numbers could make 20? Let's try doing 4 2s and see what we get. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So it's got to be a little bigger than 2. Now, the next whole number that we have would have to be 3. And if I try to multiply those together, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So when we look at these numbers, this 20 is way closer to 2 than it is to 3, because it makes 16 and 81. So I bet you that my answer when I plug this into a calculator is probably pretty close to 2. So I'm going to hit 20 raised to the 1/4 power on my calculator, hit enter, and it gives me approximately 2.115. Now I'm going to ask you guys to round off to 3 decimal places. If I took this exact number and I raised it to the 4th power, it should give me my 20 back. But if I do 2.115, it's not going to be exact, but it'll be pretty close. It's about 20, 20.0097-ish. So this is an approximation. That's why instead of putting an equal sign, I put these little, it almost looks like C waves. Okay, this means approximately. All right, now, these are some of the values that you should be able to enter in your calculator. Now, some of you guys probably knew how to do square roots, but maybe you didn't know how to do cube roots, or you definitely didn't know how to do anything to the 4th power. Okay, so this thing froze. Okay, there, I think the thing froze, so let me get it back. Yeah, this is definitely different than anything I've done before. The focus goes out of whack like every 10 seconds, and then it also freezes. Okay, so now let's look at something like this. Let's say I gave you one like this, where it has it has the root, looks like a cube root with a 4 here, and a 2 on the outside. Okay, this little guy right here, the index, is going to always be the denominator of your power. Now, if you take a look at what I wrote over here, it said for n, it was 1 over n. Well, the n value, the index, is always the denominator. That's why I wrote denominator of your power. This little value that's out here on the outside, this is going to be the numerator of your power. So I could rewrite this problem is 4 to the 2/3. Okay, now if I go to a calculator to see what that makes, so let's go 4, and I'm going to raise it, I'll put it up here, to the 2/3 power. Hit enter, it's going to give me an answer 2.520 approximately. So I'm going to put that over here, 2.520. Okay, well that's great, but the main thing I want you to get from this is we can change anything that's in radical form to basically be an exponent with a power on it, with a numerator and a denominator. Okay, so here's a little rule that we have here. I'm going to put a little star. If b to the n equals a, then b is an nth root of a. Okay, so now I'm going to give you a couple problems that should help you guys with your homework. I'm going to move this thing up a little bit. So example 1 says, find the indicated real nth roots of a. Okay, so with our formula, remember that we have the nth root of a, and this is equivalent to a to the 1 over n. Now this is something that we did at the very, very beginning of this. Okay, so now, when I look at it, okay, I'm trying to make this thing focus. The first example says it gives you that n is 5, and it gives you that a is equal to negative 243. And this is all it says. Find the indicated real nth roots of a, and it gives you this. Well, let's take these numbers and let's plug them into here. So all this is saying, if n is 5, you're going to plug that into your index, which goes here. And the negative 243 is the value that goes underneath your square root, which is negative 243. So what we have to think about is what 5 same numbers will multiply to make negative 243. Well, you could try to do this in your head, or you guys could do this. Take your base number, put it in parentheses, and raise it to the 1/5 power. And let's plug this into our calculator and see what we come up with. Negative 243, or I'll put it in parentheses, negative 243 raised to the 1/5 power. Hit enter. It gives us an answer of negative 3. Okay, now what exactly does that mean? Well, it means that if I took negative 3, and I multiplied it out 5 times, it would make negative 243. Okay, now what's the importance of this? Like, why is the answer not just 3? Well, remember, if I multiplied 3 5 times, that would make 243, but it's a positive number. The only one that can make a negative 243, now you may remember from the chapter we just did, normally if you have a negative, you pull an I out. Well, this one's a little different because it has a 5th root. You have to think of, if I had a negative on each one of these, if this is an odd power, then it could possibly be a negative. Because see how I have 5 negative numbers? These become positive, but this becomes a negative. So it is possible when you have an odd index to end up with a negative value. Okay, so let's try another one. We'll call this example 1 A, and let's try B. Okay, so for part B, it says, same type of question, n equals 8, a equals 256. Okay, so now, when you go to write this down, our index comes out here. It's the 8th power to make 256. We need to find 8 of the same numbers that multiply to make 256. So I'm going to plug this into my calculator, take 256, I'm going to raise it to the 1/8 power. Okay, so now let's plug this in. Put it in parentheses. 256 raised to the 1/8 power. When I hit enter, I get 2. Okay, now you're like, great, I'm done. But think about this. If I took 2 and I multiplied it out 8 times, 3, 4, 5, 6, 7, 8, that makes 256. But what if I took -2? Say I took -2 and I also did that same thing out 4, 5, 6, 7, 8, and I did that 8 times. It also makes positive 256 because look at how many negatives you have. You have an even number. This makes positive, this makes positive, this makes positive, this makes positive. They all make a positive amount. So not also will 2 work, but -2 will work. So the answer for this is not just 2, it's plus or minus 2. So here's your rule of thumb for doing these. When you have an odd index, and this is negative, you can get a negative value. But when it's even, that means that you could get the positive or the negative value. Okay, so odd index, you can get a negative answer. Okay, you didn't get the positive one because when I multiplied positive 3, it made 2 positive 243. But on this one, when I have an even amount, I can get a plus or minus. Okay, now the next little thing I'd like to look at, let's move, I'm going to get another piece of paper. Okay, so let's look at, oh, it looks like this thing froze again. Okay, so, all right, to do, here's the second example. Let's see if I can move this, go like that. Okay, so, there, I think it's zoomed in. Okay, these directions ask you to solve without a calculator. So I'm going to show you how to do all these calculator free. Okay, and then I'm going to show you guys how to go back and check. You can check the answer with the calculator later, but how to do these without one. All right, let's see if I can. All right, I think that's zoomed in. Okay, so part A. 4 to the 3 halves. B, 32 to the 4/5. C, 625 to the 3/4. And D is going to be 49 to the 3 halves. Okay, the key to doing these problems is the base numbers. You need to try to change all these base numbers into a smaller value. So you might remember when you guys were like when you guys learned about factor trees. I'm guessing like 7th, 8th grade. So let me talk about what I mean by factor tree. Could you take 4 and break it down? Well, 4 should make 2 times 2. Once you're done, circle them. So couldn't I write 4 is 2 to the 2nd power? Okay, now I'm going to do that with these guys down here too, but I'm just going to look at this one for right now. Okay, so now when that's 2 to the 2nd, I'm now taking this and I'm raising it to the 3/2. Now there was a rule you guys learned in Algebra 1 that said a power raised to a power you can multiply. Well, I can take these 2 and cross them out, which will make 2 to the 3rd. Well, 2 times 2 times 2 should make 8. And I bet you if I go to my calculator and I hit 4 raised to the 3/2 power, it should make 8. And it does. Okay, but I didn't need a calculator for that. I can do it without one. Okay, now let's take a look at 32. I'm going to go over here and make my factor tree. Things that multiply to make 32. 2 times 16. Okay, circle prime numbers. 2 times 8, circle prime number. 2 times 4, circle the prime number. And then 4 makes 2 and 2. So I can write 32 is 5 2s. So I'm going to write it like that. 2 to the 5th. Raised to the 4/5. Power raised to a power, I can multiply, which means I can cancel these out, which gives me 2 to the 4th. Plug that into a calculator, gives me 16. Now, I'm not going to show you on a calculator, but I bet you if you take this and you plug it in, it'll work. Okay, let's try 625. This is kind of a big number. If I take 625 and I divide it by 5, I get 5 and 125. Circle prime numbers. Now do this again. If I do 125 divided by 5, I get 5 times 25. And then I do this, and it looks like I get 4 5s. Now, sometimes you're going to run into them where they're not all the same, but for right now, in the first section of a chapter, they're pretty much always going to do this. And this is raised to the 3/4 power. Power raised to a power, cancel. This makes 5 to the 3rd. Plug that into my calculator. Okay, or you don't even need a calculator. It's basically 5 times 5 times 5. That makes 25 times 5, and I get an answer of 125. Now, we do the same thing with 49. Well, that one's easy. It's 7 times 7. So these are my two primes. I'm going to rewrite 49 as 7 to the 2nd power, raised to the 3/2. 2's cancel, and I get 7 to the 3rd, which is 3 7s. Well, 49 times 7 comes out to be 343. That's my answer for part D. Okay, now that kind of shows you guys how to do some of these problems without the use of a calculator. This is really, really handy future math, especially when you guys get into trig and pre-calc. Okay, you're going to have to know how to use these. And it's also helpful if you guys take your SATs and things like that, where they'll have questions that are kind of like this. Okay, example 3. This is the last, there's a couple of examples on this one, but this should be the last thing that should get you through your homework. Okay, so the directions say find the real solution or solutions of, and they give you, this is part A, it's 5x cubed equals 320. So when we need to find the real solutions, think of this as like I'm telling you to solve this. We need to kind of figure out what these little answers are. Oops, that should have been an E. Sorry. So I need to solve this for x. Well, I have to isolate my variable. So I'm going to write this right here. Isolate variable. Okay, well, the only way to do that is I have to divide everything by 5. Okay, so this is going to cancel. And I plug this into my calculator. 320 divided by 5, and it's going to make 64. Okay, so I'm going to put that right here. Okay, now let's think about what's going to happen here. We now have to get rid of the variable, but it's got a power of 3. So to get rid of this 3, we have to take what's called the cube root of both sides. Okay, cube root means this. The only way to make this an x to the power of 1 is to put a little power of 3 here. Because all this is going to be, if you think about it, this is the numerator of your power. This is the denominator of your power, which is going to give you 3 over 3, which is ultimately going to give you x to the 1st, or an x. Because remember, the goal at the beginning was to isolate your variable, which is what we did. Once we divided by 5 and we took the cube root, these two things will cancel, making your x isolated. Okay, but then we have this ugly looking thing, the cube root of 64. All right, this thing froze again. Let's see. All right, so we're here. Now, I'm going to write this in my calculator is 64 to the 1/3 power. Okay, so now what I'm going to do here is I'm going to plug this into my calculator and see what this makes. And I'm going to show you two different ways to do this. So we got 64 raised to the 1/3, which gives us an answer of 4. Okay, well, that's cool because calculator gave it. But what if I gave you a problem like this and I said no calculator? Well, could I rewrite 64 as something different? Well, let's do that. Let's do that factor tree thing again. 2 times 32. 2 times 16. 2 times 8. 2 times 4. 2 times 2. Now count all your 2s. 1, 2, 3, 4, 5, 6. So this is 2 to the 6th raised to the 1/3. So now power raised to a power. I can cancel those, which leaves 2 to the 2nd to the 1st. Power raised 4. Didn't need a calculator for this. I can change this into a base. 64 becomes 2 to the 6th, and I multiply those together to give me my answer. So this is part A. Okay, answer was 4. Now I'm going to ask some questions for you guys. We have to go back and check this to make sure that it works. So I'm going to go back up here, and I'm going to plug a 4 in. So this is what we're checking to see if it works. Well, you have to do the power first. So let's plug in 4 to the 3rd times 5 makes your 320. So that works. But you might be saying, well, how come does negative 4 work? I mean, we got an index of 3, that's odd, but will a negative work? Well, what if I go back in here, and instead of plugging in a 4, what if I plugged in a negative 4? Would it work? Well, let's see. Negative 4 raised to the 3rd makes negative 64. Multiply that times 5, and it gives me negative 320. So that one doesn't work. Now, how did I know it wasn't going to work beforehand? Odd power. Because it ends up being a cube root, which is an index of an odd power. The only answer that was going to work was the answer that I got. Okay, so now, last little one. This is example 3B. I'll move this down a little bit. And then my kid wrote hi on there. All right, so see if I gave you something like this. Find all the real solutions of x plus 3 to the 4th equals 24. Okay, so first thing, we want to isolate the variable. Okay, but we got a problem. There's a lot of things with the variable. We got this 3, we got this 4, we got all this stuff. So what we're going to have to do to try to isolate it, and this is our variable, is we're going to have to get rid of this power of 4 first. So we're going to take the 4th root of both sides. Okay, this is going to help us to isolate the variable. So I'm going to go like this, I'm going to go like this. And I have to put a little index of 4. Now what that's going to do is it's going to cancel these out, because remember this is the same thing as a 4 over a 4. Okay, I'm trying to make this work. It's freezing. Okay, now, all right, so this becomes x plus 3. The 4 over 4 power becomes a 1, so this is now a power of 1. And this is now the 4th root of 24. Now, to completely isolate the variable, we are going to subtract 3 from both sides. So now the x is by itself. Now here's one of the things before we finish up the problem. Take a look at what your index was. Our index was an even number. Anytime we have an even number, when we come down here, you have to remember to write plus or minus. That's a big thing that people are going to forget. If it's an even one, plus or minus. If it's an odd index, then you don't have to write anything. It's whatever answer comes out. Okay, so now we are going to get this. Plus or minus the 4th root of 24 minus 3. Okay, so now how do I do this? Well, I'm going to write this as 24 to the 1/4 power, and I'm going to plug this into my calculator. Now you may be like, can I break this down? Well, no. If you try to do 24 and did a factor tree, none of them, I mean, these two are the same, but you don't get all of them the same. You get 3, or you get 3 2s and a 3. So they have to all be the same. And if you can't do that, you have to use the calculator like this. So we're going to go to our calculator. We're going to get 24 raised to the 1/4 power. You hit enter, and it gives us a number. Now we're going to approximate this. 3 decimal places. 2.213. Then look at the next number. It's a 3, so you throw all this other stuff away. So we're going to use 2.213. Okay, so I'm going to put that right here. Plus or minus 2.213 minus 3. So here's how we generate our answers. We're going to do the plus one first, which will generate that one. And the second one is negative 2.213 minus 3. So you take the positive answer, subtract 3. That's what we did here. And take the negative and subtract 3. Well, the second one's pretty easy. It gives you this. Negative 2 minus 3 is negative 5. Now, you probably want a calculator for this. 2.213 minus 3 is negative 0.787. Now, these are the two answers that we get. So now here's what you need to check. Every time you're done and you get solutions, because you're going to get negative answers sometimes, positive answers, you're not sure. You have to plug these in to check to see if they work. Okay, this thing froze again. All right, let's go here. Okay, so we're going to take this answer to start with and plug it in there. So negative 0.787 plus 3 gives us this. Raise it to the 4th power. Okay, now and if you take a look at this number, that's pretty darn close to 24. The only reason it's not exactly 24 is because we round it off. Okay, so this answer works. Let's also try this one. Negative 5.213 plus 3 gives us this number. Okay, raise it to the 4th power, which gives us also positive 23.984, which is pretty close to 24. So both of these answers work and you get 2 solutions. Okay, rule of thumb, even power, make it plus or minus. Odd power, odd index, no plus or minus. Just take whatever answer you get there. Okay, guys, this should give you guys enough to start your homework, and I will be back next week. All right.